Hello, I am Pratham Sir, and this is my submission for Kaggle Assignment 1. My roll number is 23F2003391. Okay, first of all, we have the default code block. It's used to split the data. Okay. Then we will import the training data set, and we will also ignore the warnings. The first rubric was to identify the data types of different columns. So from .info we can do that. And as you can see, we have one integer, 4 float, and 4 object data types. The statistical description of numerical columns can be found from describe, and we can find the medians from .median. Okay, so the medians for bath and balcony are both 2, while total square feet is 1280 around, and price is 72. As from the other statistics mean max, you can see there is a lot of variance in total square feet as well as price column. Otherwise, it's for bath and balcony, the variance is pretty low. Okay, so now first the third step will be to identify and handle the missing values. We can identify by doing .isNA, and as you can see, we have 586 missing values, mostly in balcony, and some in bath, total square feet size, and only one in location. Rest have no missing values. Sometimes the values present can be also in the form of infinite values, so we can check that as well. But no, this is not the case in this assignment. In the values we have been provided. Now we have to handle it. So we can use simple imputer for that, and I have created a column transformer. What I thought was that we can use the mode for filling location and size at they are non-numeric data, and mean can be used for square feet, while median can be used for bath balcony. This is my column transformer. Now we will fit it and we will see whether there is any missing values remaining. So as you can see, there are no missing values present after transforming it, after imputing it. Then we have to find and identify the duplicates. There are no duplicates. We can do that by .duplicated value, but there are no duplicates. And now we will identify and handle the outliers. So basically, outlier handling can be done by, the standard method is to be done by box plot, but yes, and it's a pretty effective way to find outliers. But sometimes when the variance is too big, there will be a lot of outliers. So I have plotted the box plot, and yes, so there are like 900 outliers in total square feet in bath, 781, 0 in balcony, but 966 in price. Okay, this is the code for finding outliers. Basically, we define the quartile range. Q1 is the 25th percentile, Q3 is the 75th percentile, and the IQR is Q3 minus Q1, which is the range between 25th and to 75th percentile. And we just find the lower bound to be Q1 minus 1.5 times IQR, and upper bound to be Q3 plus 1.5 into IQR. Okay, so for evaluation and test purposes, I have transformed the data set into log, but kept the original imputed as well with outliers. We can see the comparison performance as well. Okay, so after transformation, you can see the price factor has reduced quite a bit, as well as total square feet factors, bath factors as well. Okay, and to provide some visualization, let's compare original price distribution, which is very heavily left skewed, and to our log transform price distribution. It's relatively less skewed, more resembling normal, though it's still left skewed, but then also. Now we can plot total square feet versus price as well, and from the graph you can see there's a heavy correlation. Although the slope is bit steep, but the correlation is present. Okay. So we can conclude that for certain, for less increase in total square feet after certain points, the increase in price is heavy. And also for some other statistics, we have average price by area type. So our data type had 4 area types, which was type 1, type 2, type 3, type 4. But now we can see that type 3 is the most expensive area type, while type 1 is lower. But the gap between second highest and highest is a lot. Now we will scale the numerical features and encode the categorical features. So okay, we have to first create a column transformer, and for that we will scale the numerical columns, while we will encode the categorical columns using one hot encoder, and I have used standard scaler for numerical columns. Okay, so we have to now build the model. I haven't applied the preprocessor yet. We will do it after building the model. Okay, so now we have to build 7 models. So I have selected 9 of them, which are linear regression, reach, lasso, SGD, KN neighbors, KNN, SVR, KN regression, sorry, not neighbors, SVR, decision tree regressor, random forest, bagging, ADA boost, MLP, and I have created a function so we can test the outliers dataset and transformed log dataset, means the original and the log transformed datasets, and then I fitted the model, and in the pipeline only I have transformed it using our preprocessor that we have defined before using the column transformer. Okay, so the model performance summary for the outlier dataset is okay. Linear regression is negative something because it will be skewed heavily, but the rest of them are okay. Only the standing is MLP regressor, which has a score of 0.59, but this will change in the log adjusted dataset. Still, the linear regression is giving very heavily negative score, but the rest have been improved. Instead of just for some reason lasso has decreased, has significantly decreased. Otherwise, rest all have significantly improved, with the standout being SVR. Okay, so the score of top 3 I have visualized for both the graphs. For with outlier for the original data without log transformation, the top 3 are MLP, random forest, and bagging, while for the log adjusted dataset they are SVR, reach, and MLP regression. Okay, so the best model is SVR with the score R2 score of 0.8168, which is good, although it can be better. But now I am hyper tuning it, so let's see if there is any performance increase. So I have chosen the top 3 performing models of log adjusted dataset, which is SVR, reach, and MLP, and hyper tuned them with a bunch of parameters. After tuning, let's see the result. Okay, so SVR has just a marginal improvement, which is 0.8173 instead of 0.816, which is very less, and rest have okay improvements, with reach having 0.7824 and ML regressor having 0.791. Now we will compare the performance, and we can find the best is after cross-validated R2 score is that of SVR only, and we have hold out the validation set, and in it has improved slightly from 0.8173 to 0.8201. Now we will read the test file and apply the transformation in that as well. And yes, after that we will just extract the file to submission.df, and you can see the head of the submission.df. Okay, yes, that's it, and the final score is of, as mentioned before, was of 0.67093, and it took a lot of time to run. Thank you.